let's talk about something really fundamental. How do we measure the world around us? And how do we even begin to describe everything that moves through it? You might think these are simple questions, but the answers, well, they're the foundation for pretty much all of science. Today, we're breaking down two of the biggest ideas we have: motion and measurement.
I mean, just think about that leap for a second. It's huge, isn't it? From our ancient ancestors just walking around to us right now sending rovers to explore the surface of another planet. That entire incredible journey, that whole story of human progress, it all comes down to one absolutely crucial skill: our ability to accurately measure distance and motion. So to really get how we got here, we've got to go back in time and look at how we moved. Because the story of transport is really the story of humanity figuring out how to conquer distance. Just look at the pace of change here. For thousands and thousands of years, things were pretty slow. We had our feet, we had animals, we had simple boats. The wheel, now that was a massive game changer for sure. But then, bam, everything just takes off. In just a couple of centuries, we go from the very first steam engines to literally landing on other worlds. So how did that happen? Well, that incredible leap was only possible because we first had to solve a much, much smaller problem right here on Earth. And this fundamental breakthrough, it didn't come from some fancy laboratory or a brilliant astronomer. Nope. It all started with a conflict that's probably a lot more familiar to you: a simple argument over a desk. So let me introduce you to Paheli and Bujo. They share a desk, and like a lot of people who share a space, they're constantly arguing that the other person is taking up too much room. Finally, their teacher steps in and says, "Look, just measure the desk and draw a line right down the middle." Simple. So they get this clever idea. They grab what's right there next to them, a jilly and a danda. They're basically just two sticks of different lengths that are used in a popular game. And they decide, okay, these will be our measuring tools. And at first, it works like a charm. The desk is exactly 2 danda lengths plus 2 gilly lengths long. So to make it fair, they each get 1 danda and 1 gilly's worth of space. Perfect. Problem solved, right? Everybody's happy. Well, that happy piece lasts for maybe a few days. The line they drew gets wiped off, and in that time, Bujo has lost his original set of sticks. So he just brings in a new gilly danda set to measure it all over again. And that's when things get messy. With this new set, the desk measures 2 danda lengths, 1 gilly length, and then there's this weird little bit of space left over. It's not a clean measurement anymore. So who gets the extra bit? How can they possibly divide it fairly now? Their whole system has just completely fallen apart. So what went wrong here? I mean, it's the exact same desk, but suddenly the numbers are all different. Why don't their measurements match? Answering that one simple question would end up changing the entire world. You see, Paheli and Bujo's problem wasn't just their problem. For most of human history, pretty much everyone on Earth was dealing with this exact same issue. It was time to create a universal ruler. For thousands of years, people just used whatever was convenient, and usually that meant their own bodies. A cubit was the length of your forearm. A foot? Well, that was the length of your foot. A yard was the distance from your chin to your outstretched fingertips. But you see the problem, right? My foot isn't the same size as your foot. My arm isn't the same length as yours. It led to constant confusion and arguments. The big solution? The aha moment that fixed all this chaos was the idea of a standard unit. A standard unit is simply a measurement that is known and fixed. It never, ever changes. It doesn't matter if you're tall or short, whether you're in one country or another, the unit is always, always the same. And this incredible idea finally became a reality back in 1790. The French created a totally new system of measurement built on these standard units, and they called it the metric system. And honestly, it was a complete game changer for science, for trade, for everything. The beauty of this system, which we now call the International System of Units, or SI units, is just how simple it is. It all starts with one base unit for length: the meter. Need to measure something smaller? Easy. You just divide it into 100 little parts, called centimeters. Need to measure a really long distance? No problem. Multiply it by 1,000 to get a kilometer. It's clean, it's logical, and most importantly, it's universal. Okay, so we've cracked the code on measuring distance. We have this amazing, reliable tool in our hands. Now what can we do with it? Well, now we can finally start to tackle the next big concept: describing things that are in motion. So what is motion, really? When you get right down to it, it's just a change in an object's position over a period of time. That's it. If a book is on the table now and on the floor a second later, it's been in motion. A super simple idea, but an incredibly powerful one. And what's cool is when you start really watching the world, you notice that motion tends to fall into a few key patterns. First up is rectilinear motion. It's a fancy word that just means moving in a straight line, like a soldier marching in a parade. Then you've got circular motion, where an object moves around a fixed point, like the hands of a clock. And finally, there's periodic motion, which is any movement that repeats itself over and over, like a child on a swing, going back and forth. But let's be real, the world is way more complex and interesting than just one type of movement at a time. The coolest stuff happens when these different rhythms start to combine.
So, the big question is, can an object have more than one of these types of motion happening at the exact same time? Oh, absolutely. In fact, you see it happening all around you every single day.
Let's just take a super simple example to see how this works. Picture a ball rolling across the floor. It looks like one smooth action, but there are actually two different types of motion happening in perfect sync.
So first, the ball as a whole is moving from point A to point B in a straight line. That's rectilinear motion. But at the exact same time, the ball itself is spinning on its axis. That's a type of circular motion or rotational motion. Two types of motion happening in one object at the same time. And once you grasp this, you start seeing this beautiful combination of measurement and motion absolutely everywhere. It describes the way a butterfly flutters, the way a river flows, and even the majestic way the moon orbits the Earth. These two fundamental ideas are literally the building blocks for understanding our entire universe. Think about it. We went from a petty argument over a desk all the way to charting the paths of planets, all because we figured out a standard way to measure things. It gave us the power to truly understand and describe our world. So that leaves us with one last big question. Now that we can measure motion with such incredible precision, what are we going to discover next?